Section A.6 is completing the square in the quadratic formula. So I have an equation here, 2x squared minus 4x minus 1 is equal to 0, and we want to solve by completing the square. So for the first one, we're going to complete the square all on one side of the equation. And the first step is to factor out anything that's multiplied by your squared term. We don't want to divide it away completely, so we're just going to factor it out of anything that has an x in it. So I factored the 2 out of the x squared, I'm left with x squared. I factored the 2 out of the negative 4x, so I'm left with negative 2x. So then I'm going to leave a space to complete my square and close my parentheses. I'm going to keep my negative 1 where it is, and then I'm going to leave another space to complete my square. So you have to remember that equations are like balance beams. They're like scales. Anything you do has to stay balanced. So if I'm going to add something to my equation, I'm going to have to subtract something off on the same side. That way it balances out to 0. So now we have to figure out what we're going to add. So what goes in this empty space here is b over 2 b divided by 2 quantity squared. That only works if you have factored out this leading coefficient. If you haven't factored out the leading coefficient, it's actually b over 2a. But we factored it out, so we're just going to divide it by 2. So 2 divided by 2 is 1, quantity squared is 1, so I'm going to add a 1 there. So now whatever you add, you also have to subtract back off. But we didn't actually add 1, we actually added 2 times 1. So we really added a 2, so I'm going to subtract a 2 back off. So now for the binomial part, you're going to bring down your leading coefficient, then you're going to have a binomial squared. I'm going to combine like terms over here on the right, so minus 3 is equal to 0. So now inside the binomial, it's the square root of the first one, so the square root of x squared is just x. The square root of the back one, or whatever it was before you squared it here, so that's just going to be a 1, and then you keep your sign the same. So 2 times x minus 1 quantity squared minus 3 is equal to 0. So now we have it in our completed the square form. Now we need to solve. So go ahead and pause the video and solve for x. So I'm going to isolate the quantity squared, so I'm going to add 3 to both sides, and then I'm going to divide both sides by 2, so I get x minus 1 quantity squared is equal to 3 halves. Now I need to get rid of the squared, so I'm going to square root both sides. Whenever you take the square root to solve an equation, you need plus or minus. So you get x minus 1 equals plus or minus the square root of 3 over 2. Add 1 to both sides, you end up with x is equal to 1 plus or minus root 3 over 2. You cannot divide this 2 away too early. You have to wait until you're solving, because when we go to graph these parabolas, this 2 has meaning as part of our transformations. So now in this one we have x squared minus 6x is equal to 13. On the previous example I showed you how to complete the square on one side of the equation. Now I'm going to show you how to complete the square on two sides of the equation. So your first step is the same, factor out any coefficient of your squared term. I don't have any, so I'm going to jump right into the leaving my spaces. So I'm going to have x squared minus 6x plus leave a space equals 13, and I'm going to plus leave another space. So in the previous example, since we were working only on one side of the equation, when we added something we had to take the same thing back off that same side to keep it balanced. On this one we're adding something to one side of the equation, so to keep the equation balanced we need to add something to the other side of the equation. So now from here, find the number that we're going to add to complete the square. So we're going to add a 9. 6 divided by 2 is 3. Quantity squared is 9. And then on the right side, because we don't have any leading coefficient out here, we're really added a 9 to the left side, so we're going to add a 9 also onto the right side. So now write your perfect square binomial on the left side. So now you have x minus 3 quantity squared, and if you simplify the right side, you get is equal to 22. So go ahead and finish solving this equation for x. So square root both sides to get rid of the square, you end up with x minus 3 is equal to plus or minus the square root of 22. Add 3 to both sides, you end up with x is equal to 3 plus or minus root 22. So now we have a new equation, 3x squared plus 2x minus 1 is equal to 0. Go ahead and pause the video and complete the square. So first you factor out the 3 in front out of anything that has an x in it, so you get 3 times the quantity x squared plus 2/3 x plus leave a space. Close your parenthesis, minus 1 minus leave a space is equal to 0. So you end up with a fraction here. So divide by 2, divide 2/3 by 2 and square it. You end up with 1/3 quantity squared, which is 1/9. but we really added 3 times 1/9, so we really added a 1/3, which means we need to subtract 1/3 back off. So then you end up with 3x plus 1/3 quantity squared minus 4/3 is equal to 0. So if you haven't already done so, go ahead and pause the video and solve for x. So I added 4/3 to both sides and then divided both sides by 3, so you get x plus 1/3 quantity squared equals 4/9. Square root both sides, you get x plus 1/3 is equal to plus or minus 2/3 because both 4 and 9 are perfect squares. Subtract 1/3 from both sides, you get x is equal to negative 1/3 plus or minus 2/3. So negative 1/3 plus 2/3 is a positive 1/3. Negative 1/3 minus 2/3 is a negative 1. So the fact that these are not square roots in the answer means that this would have factored in the beginning, but you can still solve it using completing the square. So now we have one more. We have ax squared plus bx plus c is equal to 0. And I want you to go through the same steps to solve this by completing the square. So completing the square with a literal equation, I factored out an a to start, so you're left with a squared plus b over ax plus leave your space plus c minus leave your space is equal to 0. So middle term b over a, whatever the middle term is, divided by 2 quantity squared, so you end up with b over 2a quantity squared, which is b squared over 4a squared. But we didn't really add b squared over 4a squared, we really added a times that. So one of the a's in the denominator cancels. You're left with b squared over 4a that you add to the subtract back off is equal to 0. So if you go down to perfect square form, you get a times x plus b over 2a quantity squared. And then I combined like terms here. I made a common denominator, and you end up with 4ac minus b squared all over 4a. So I subtracted this term off from both sides, and you're left with a times x plus b over 2a quantity squared is equal to b squared minus 4ac all over 4a. So I divided both sides by a. A's over here cancel. You're left with x plus b over 2a quantity squared. 4a, this divided by a ends up being 4a squared in the denominator, so you get b squared minus 4ac all over 4a squared. Square root both sides. You end up with x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 2a, because the square root of 4a squared is 2a. So subtract b over 2a from both sides, and you end up with x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, which is the quadratic formula. The quadratic formula is derived exactly from completing the square on the literal form of the quadratic. So this has been completing the square and then the quadratic formula here at the end. 2 more options for solving quadratic equations if factoring doesn't work.